I want to finish my improper integral explanation by doing some examples from type 2. So type 2, to remind you, are the ones that it doesn't have an infinite boundary, but it has either a boundary number or a value between the boundary numbers that creates a discontinuity within the function. So we fix these with one-sided limits because there will be a number that we can't plug in, but we can get really close to it. A lot of the wording on these, just kind of flipping through like your Barron's book or old AP tests, a lot of times the wording will simply say, does it converge or diverge? Or is this a diverging improper integral? And that's their way of saying we need to go through this process. We need to see, do we get a finite number or do we get an infinite value? So the first two I want to go through and do with you are the ones that have an issue with the lower boundary. I want you to see a little bit of everything here. So my lower boundary is an issue in both of these because both of these, if I put 0 in, I do get an undefined value for my function. So the way that we fix that is we take our limit, and we can't start at 0, so we have to start just after 0. So that's a one-sided limit. 1 over x cubed, or I could write it as x to the negative 3. I need to make this a different letter. Let me call it a, since it's a lower boundary. Sorry, let me try that again. So let's do the limit as a goes to 0 from the right. So then we're going to go from a to 2. So our steps, our checklist is, first we set up the limit form of this improper integral. Second step is to integrate using known rules. So power 1 greater divided by that power. So we get a negative 1 over 2x squared. Put your boundaries in, so a and 2. So I have negative 1 over 2 times 2 squared, 2 times 4 is 8, minus a minus, so plus 1 over 2a squared. And now I want to see what happens when I put 0 in for a. Now I am 0 from the right, but in this case, when we try to plug in 0 directly, we're going to get an indeterminate form. We're going to get 0 on the bottom here. So we're going to see what happens if I put a number that's really small, close to 0 on the positive side. Well, what's going to happen is this denominator is going to get really small, which is going to make this entire fraction get really big. So we're going to end up with a negative 1/8 plus something that gets really, really big. Infinity always wins. So we get an infinite improper integral, which means it is a diverging improper integral. So again, if I can't plug in the number directly when I'm doing a one-sided limit, then I need to think about what happens if I plug in the number that it's approaching. So it's getting really close to 0 from the positive side. So think about what happens if you put in like 0.01 or 0.0001. You get a really small denominator in this case, which gives you a really big fraction. Same issue on this next one. So we are going to fix the limit notation as we approach 0 from the right, because I can't put 0 in, so I'm going to start right after it, from a to 1. And I'm going to write this as x to the negative 1/3. Power 1 greater divided by that power. Let's see, power 1 greater is going to be the 2/3. So I'm going to get 3/2 x to the 2/3 from a to 1. So I'm going to get 3/2 1 to the 2/3, which is just going to be 3/2, minus 3/2 a to the 2/3. So this first part's just 3, I keep saying 2/3, 3/2, excuse me. When I put 0 in here, now I can put 0 in directly. It doesn't give me something that's undefined. When I put 0 in and take it to the 2/3 power, I'm going to get 0. So this whole thing is going to go to 0. So I am left with a finite value of 3/2. So we would say this is a converging improper integral because it gets a finite number as your answer once you evaluate the limit. So let me show you two that are the opposite issue. The upper boundary is the problem, so you have a better idea of how to correct it and then how to deal with it. So if your upper boundary is the problem, so 6, upper boundary is the problem. The second one actually has another issue. We'll get to that in a second. So upper boundary is a problem. So now we're going to take the limit as, I'm going to call it b since it's the upper boundary, is going to approach 6, this time from the left, because I can't get all the way to 6, but I can stop right before. So I'm like starting at 2 and then going up to right before 6. So my integral from 2 to b of 5 over x minus 6. So again, the process is figure out how to integrate it. This is a natural log integral. So the 5 can just come out front. 5 natural log of x minus 6. I'm going to put my boundaries in. So 5 natural log of b minus 6 minus 5 natural log of 2 minus 6. So we need to see what happens when we put in a number that's a little bit smaller than 6 and subtract 6 from it. So if I take a number a little smaller than 6, like 5.99, and I subtract 6, I'm going to get a really small negative number. I'm going to get like negative 0.01. The absolute value bars will get rid of the negative. So what you're going to have is you're going to have the natural log, and I'm just going to write it like this, of a really small number heading towards 0. So if you think about natural log, it's always helpful to think about the visual. As natural log is being taken of something closer and closer to 0, I'm going to go down to negative infinity. So again, let me restate what I just said. When I'm taking the natural log of something and it's getting closer and closer to 0, so the natural log, I can't take the natural log of 0, that doesn't exist, but like the natural log of 0.01, it's going to be really small. It's going to go to negative infinity. Times 5 is negative infinity. Over here, the absolute value is going to get rid of the negative there. So instead of the natural log of negative 4, it's going to be the natural log of 4. But in the end, it's going to be a finite number that's going to be subtracted from negative infinity. Well, negative infinity will always win whenever added or subtracted to a finite number. So this one we would say diverges because we get an infinite answer. The last one here is the worst case scenario. What do you do when it's a number between? You are not going to see a lot of these because they are a pain. The problem is the discontinuity is 1. So I'm just going to make a little note here as to what the issue is. So what I can do is I can take the limit as we approach 1 from the left of x minus 1 to the negative 2/3. That's a b up there. And then I can add that to the limit as I approach, we'll call that a, 1 from the right, a to 2 of x minus 1 to the negative 2/3. Complete pain because you have to do it as 2 separate pieces. Now, the one good thing is they're both going to integrate the same. It's both the exact same integral. It's just your boundaries and the limit piece that's different. So my integral, this is just a really quick use of with no adjustment. It's u to the negative 2/3. I'm just going to kind of write that down here. So power 1 greater would be 1/3. So we get 3u to the 1/3. So we get 3x minus 1 to the 1/3, going from 0 to b. So when I put my values in, 3b minus 1 to the 1/3 minus 3 negative 1 to the 1/3. So b is putting a number in that's really, really close to 1 from the negative side. So like 0.99, I subtract 1, I'm going to get a really small negative number. To the 1/3 power is going to be an even smaller. It's going to get smaller. This is going to go to 0. Again, because I'm taking a really tiny number to the 1/3 power, I'm cube rooting, it's just going to get smaller and smaller. This over here, negative 1 to the 1/3 is negative 1 times negative 3. I'm going to get 3 for that part. Now I'm going to do the same thing over here. When I integrate, I still get 3x minus 1 to the 1/3, going from a to 2. So I have 2 minus 1 is 1 to the 1/3. Minus 3 times a minus 1 to the 1/3. So now I'm putting a number in that's really close to 1, but just above it from the right side. So think of it as like putting in like 1.01. When I take that and subtract 1, I get a really small number. When I take it to the 1/3 power, it gets even smaller. So this is going to go to 0. So I have 3 for this part. So my first part, it gives me a limit of 3. My second part gives me a limit of 3. When I add those together, I get a limit of 6. Therefore, this converges. The challenge with this is you do have to do it 2 separate pieces. Same integral, but your boundaries are different. The evaluation of the limit can be different because you're putting in a number from the left side and for the one integral, and then from the right side for the other integral. I just want to show you a wording of a question. This one's much faster, but this will be the last thing we're going to look at. So I just cut and paste this straight from the Barron's book. Sometimes you are lucky enough to get a question that is like this, which is simply saying, what's going to make it improper? Like which one of these is improper? So if it had an infinite boundary, that would be easy. There's no issue there. So now we're looking at which one would have one or more discontinuities in the bottom, and then we look at the boundaries to see if it's there. So let's see. Well, let's start with this one. Let's see, what would make that bottom undefined? -1 would make that bottom undefined because if I put -1 in, I'd get the square root of 0. But -1's not my boundaries, so this one is not improper, so that's out. This one, this denominator will actually never equal 0. There is nothing I can put in there. Even if you might think, well, what if I put in -1? Well, I still get -1 squared is positive. I can put 0 in. This one's good. That's actually an arctangent integral. This one, let's see, if x equaled 1 or -1, I would get a denominator that equals 0. And if I look at my boundaries are 0 to 2, so 1 is in there. So here is my winner. This is an improper integral because of x equals 1. So I would have to break this into two separate integrals like the one we just did. Last piece, just to look here, cosine equals 0 at pi over 2, and that's not in my interval range. Now, if this was flip-flopped, if the sign ended up on the bottom, the sign of 0 is 0, so that would be a problem, but this one is good. So the only one out of this group of 4 that is improper is choice C. Wanted you to see just sometimes that's what they want to know is what is improper, what makes it improper, which one is improper. Sometimes you'll see multiple choice questions that give you a group and want to know which one out of the group is diverging. Those can be a little more time consuming, but this is a quick way to ask the same type of question.